January 28, 1986. A physicist sits at a government hearing table, a glass of ice water in front of him. Cameras roll as NASA officials deliver carefully prepared testimony about the Space Shuttle Challenger disaster that killed 7 astronauts 6 weeks earlier. The physicist isn't listening. He's watching a rubber ring soak in the ice water. Then, mid-testimony, he interrupts. He removes the ring with a small clamp, holds it up to his microphone, and squeezes it. When he releases, the rubber stays compressed. "I discovered that when you undo the clamp, the rubber doesn't spring back," he says into the microphone. The room goes silent. In 30 seconds of unauthorized demonstration, Richard Feynman just destroyed months of NASA's carefully constructed narrative. This comes directly from Feynman's documented testimony to the Rogers Commission, February 11, 1986, and his later account in What Do You Care What Other People Think?, published in 1988. The ice water demonstration became the defining image of the investigation, but the story of how a Nobel Prize-winning physicist ended up embarrassing NASA on live television reveals something far more valuable than what happened to a rubber seal. 6 weeks earlier, on that January morning, Feynman was at his Caltech office when the Challenger exploded 73 seconds after launch. He watched the footage like everyone else, the white trails diverging against blue sky, the cabin tumbling toward the ocean. Krista McAuliffe, the teacher who was supposed to inspire a generation about space exploration, died along with 6 other crew members. President Reagan announced a commission to investigate, and then Feynman's phone rang. William Rogers, the former Secretary of State leading the commission, wanted him to join. Feynman said no. He was 67, fighting cancer for the 2nd time, and he'd spent a career avoiding government committees. "I don't know anything about rockets," he told Rogers, but Rogers kept calling, so did NASA. They all wanted the credibility a Nobel laureate brings. Feynman understood this game. Put famous scientists on a panel, let engineers write the report. Everyone signs off, nothing changes. He'd seen it before. He told his wife Gwyneth, "They don't want me to investigate. They want me to give them legitimacy." But Gwyneth saw something he didn't. "You're going to do it anyway," she said. "You'll spend every day reading about it in the newspaper, getting frustrated that they're asking the wrong questions. You might as well be there." She was right. 3 days later, Feynman flew to Washington. The first commission meeting revealed exactly what he'd feared. 12 distinguished members sat around a table while NASA presented slide after slide of technical data, charts, graphs, acronyms. The other commissioners nodded along. Feynman raised his hand. "What's an SRB?"
Suggestion of a temperature at which the SRB, I guess you call it,
Yes, sir.
shouldn't be run.
Yes, sir. There was.
Silence. Nobody wanted to admit they didn't know either. "Solid rocket booster," someone finally said. Feynman kept his hand up. "What's an SRM?" More silence. These were the people investigating a rocket disaster, and they didn't know basic terminology. That's when Feynman understood the real problem wasn't technical. He started his own investigation that night. While other commissioners attended official dinners and briefings, Feynman took a taxi to NASA's Jet Propulsion Laboratory in Pasadena. He knew engineers there, people who designed things, built things, people who actually touched hardware. "Show me how this works," he'd say, pointing at technical drawings. They walked him through every system, and whenever they used a term he didn't know, he stopped them. "Explain it to me like I'm 5, he'd demand. Not because he couldn't understand complexity, but because he'd learned something crucial years earlier in his physics research. If someone can't explain something simply, they don't actually understand it themselves. This wasn't just stubbornness. This was a method. Feynman had discovered that expertise creates its own form of blindness. Engineers at NASA had been launching shuttles for years. They'd developed specialized language, internal assumptions, comfortable ways of thinking that nobody questioned anymore. An outsider asking stupid questions forces them to examine those assumptions, and in those examinations, truth emerges. But the official hearings continued in their scripted way. NASA executives testified about procedures and protocols. They showed videos of previous successful launches. They emphasized the shuttle's safety record, 24 missions without catastrophic failure. The message was clear. This was a freak accident, an unforeseeable tragedy. Feynman sat through these presentations, watching commissioners accept the narrative. Then he started hearing different stories. Late one evening at JPL, an engineer pulled him aside. "We knew about the O-rings," the engineer said quietly. "The seals on the solid rocket boosters. They've been eroding for years. We've seen it in post-flight inspections. We wrote reports." Feynman's antenna went up. "What reports?" The engineer looked around nervously. "They're classified. I shouldn't even be telling you this. Here's where most people would have moved cautiously, gone through official channels, requested proper access. Feynman did the opposite. The next morning, he called the engineer back. "I'm on the commission," he said. "I have clearance. Send me everything." Within 48 hours, he had documentation that NASA had known about O-ring erosion on previous flights. Engineers had recommended not launching when temperatures dropped below 53 degrees Fahrenheit. The morning of the Challenger launch, the temperature at Kennedy Space Center was 36 degrees. The rubber O-rings created a seal between segments of the solid rocket boosters. When cold, the rubber became less flexible. Less flexible meant slower to seal. Slower to seal meant hot gases could escape during ignition. Escaped gases meant catastrophic failure. Engineers had explained this to management. Management had launched anyway. But this wasn't in any official testimony Feynman had heard. He brought the documents to the next commission meeting. William Rogers wasn't pleased. "We need to follow procedures," Rogers said. "We can't just ambush NASA with unauthorized information." Feynman looked at him. 7 people are dead," he said. "What procedure is more important than that?" This moment captures something essential about how institutions corrupt truth. Rogers wasn't a bad person. He wasn't trying to cover up the disaster. But he'd spent decades in government, learning how things work, understanding that investigations have rhythms, protocols, political considerations. You don't embarrass powerful agencies publicly. You negotiate findings privately. You write diplomatic reports. Everyone saves face. The machine keeps running. Feynman didn't care about the machine. He'd never learned those rules, never wanted to. His entire career had been built on a different principle. Nature doesn't negotiate. Physics doesn't care about your protocols. A rubber seal either works at 36 degrees or it doesn't. The truth is the truth, regardless of who it embarrasses. But he still needed proof that anyone could understand. Technical reports weren't enough. Commissioner's eyes glazed over at engineering specifications. He needed something visual, immediate, undeniable. That's when he thought of the ice water. The night before the February 11th hearing, Feynman sat in his hotel room with a piece of O-ring material he had obtained from NASA. He dropped it in ice water from the minibar. After a few minutes, he removed it and squeezed it with pliers. When he released the pressure, the rubber stayed compressed. It had lost resilience. He did it again. Same result. It was such a simple test. A child could understand it. Why hadn't NASA executives mentioned this in their testimony? The answer reveals how expertise creates distance from reality. NASA's leadership weren't engineers anymore. They were managers, administrators, people who read reports written by other people who read reports. They dealt in abstractions, acceptable risk percentages, mission success probabilities, cost-benefit analyses. Somewhere in that chain of delegation, the physical reality got lost. Nobody at the top was actually squeezing rubber in ice water. They were managing the process of managing the people who managed the engineers. So, Feynman walked into that February hearing with his simple demonstration planned. But Rogers had gotten wind of it. Before the session started, he pulled Feynman aside. "Don't do anything dramatic," Rogers said. "Let's present findings methodically through proper channels." Feynman nodded. Then, during NASA's testimony about component reliability, he interrupted anyway. The ice water demonstration wasn't just scientific theater. It was a statement about how truth works. You don't need committees and subcommittees and 6-month studies to understand that cold rubber doesn't spring back. You need ice water and eyes. NASA had spent weeks crafting testimony about anomalous joint performance and thermal environments outside certified parameters. Feynman showed that all those words meant it was too cold and the rubber broke. The footage of that moment shows something fascinating. Watch NASA officials' faces when Feynman holds up the compressed O-ring. There's no surprise there, no shock, just resignation. They already knew. They'd known for years. What Feynman had done wasn't reveal new information to NASA. It was reveal to the public what NASA had been hiding from itself, because that's the sophisticated form of institutional lying. NASA engineers hadn't sat in a room and decided to deceive the public. They'd participated in something more insidious, a bureaucratic process where uncomfortable truths get filtered, softened, contextualized, and eventually buried under layers of management review. An engineer writes, "Do not launch below 53 degrees Fahrenheit." A manager reads, "Launch constraints exist at certain temperatures." An executive hears, "There are some temperature considerations." A politician announces, "NASA maintains rigorous safety standards." Nobody technically lied. The truth just got progressively diluted until it stopped mattering. Feynman's ice water demonstration shorted out that entire circuit. It went directly from physical reality to public consciousness, bypassing every filter. Rogers was furious. NASA was humiliated. But the truth was now undeniable. 6 weeks later, NASA officially acknowledged that O-ring failure caused the disaster, and that management had overruled engineer recommendations not to launch. But here's what makes this story more than just a historical anecdote about one commission. The same pattern repeats constantly in modern organizations. Right now, in companies around the world, someone knows something important is broken. They've written reports, they've sent emails, they've voiced concerns in meetings, and somewhere between their keyboard and executive action, that knowledge is being filtered, softened, contextualized, and buried. You've experienced this. You've been in the meeting where everyone knows the project is failing, but nobody says it directly. You've seen the product ship with known defects because the launch date was politically important. You've watched companies promote confident incompetence while ignoring knowledgeable skeptics. The Challenger disaster wasn't an anomaly. It was bureaucracy working exactly as bureaucracy works, optimizing for internal harmony over external reality. Feynman understood this because he'd built his career on a different principle. In physics, you can't manage reality. You can't have a meeting with the universe and negotiate better laws. Nature is the ultimate honest broker. Your theories either match observations or they don't. This created in Feynman a almost physical revulsion to intellectual dishonesty. He couldn't tolerate watching smart people lie to themselves through sophisticated language. The Rogers Commission eventually published its report. It was diplomatic, measured, carefully worded. But Feynman wasn't satisfied. He wrote his own appendix, published separately, that was characteristically blunt. For a successful technology, reality must take precedence over public relations, for nature cannot be fooled, he wrote. NASA had spent years doing public relations about safety. Nature responded by killing 7 astronauts. This appendix reveals Feynman's deepest insight about expertise and authority. NASA's leadership weren't stupid or malicious. They were sophisticated people who'd convinced themselves that managing risk was the same as eliminating it. They'd built elaborate systems for tracking problems, reviewing concerns, assessing probabilities. The systems made them feel scientific and rigorous. But systems can't replace actually squeezing rubber in ice water and watching what happens. The same trap awaits anyone in a position of authority. The higher you rise in an organization, the more your information comes filtered through other people. You read reports instead of observing directly. You hear summaries instead of seeing data. You make decisions based on presentations instead of reality. This isn't laziness, it's how organizations scale. But it creates a dangerous distance between your understanding and the truth. Feynman's method offers a solution, though it's uncomfortable. Never trust information you haven't verified yourself. When someone tells you the product is ready to ship, ask to see it. When engineers say something is safe, ask them to demonstrate it. When executives present optimistic forecasts, demand to see the underlying assumptions. This doesn't mean rejecting expertise. It means refusing to accept authority as a substitute for evidence. This principle applies beyond corporate failures. Consider how you consume information daily. Experts on social media make confident claims. Companies publish research that coincidentally supports their products. News articles cite studies show without linking to studies. Everyone's selling a version of reality that serves their interests. Feynman's ice water test asks, can you demonstrate this simply? Can you show me the actual evidence? Or are we just managing words? The same question applies to your own expertise. When you explain your work to someone outside your field, can you make it concrete, or do you retreat into jargon and complexity? When someone questions your conclusions, can you show them the evidence, or do you appeal to credentials and authority? Feynman's standard was brutal. If you can't explain it clearly, you don't understand it. And if you don't understand it, no amount of sophisticated language makes it true. But there's a cost to this approach. Rogers never forgave Feynman for the ice water demonstration. NASA officials resented him for years. Other commission members thought he'd violated protocol and embarrassed everyone. He'd broken the unspoken rules about how investigations work. You find the truth privately, then present it diplomatically, giving everyone time to prepare their responses and save face. Feynman's response captured his entire philosophy. I don't care about saving face. I care about saving lives. This sounds heroic in retrospect, especially when you're on the right side of history. But it's genuinely difficult in the moment. Speaking truth to power means making powerful people uncomfortable. It means being excluded from future opportunities. It means watching colleagues who play the game advance while you're labeled difficult. Yet Feynman believed this was the only honest way to live. In his later interviews, he reflected on the investigation. I believe that a scientist looking at non-scientific problems is just as dumb as the next guy. And when he talks about a non-scientific matter, he sounds as naive as anyone untrained in the matter. But I think I'm as dumb as the next guy about everything but science. But when it comes to science, I have a special knack for getting to the truth. That special knack wasn't mysterious. It was treating reality as the ultimate authority. It was refusing to let sophisticated language obscure simple facts. It was being willing to look stupid by asking basic questions. It was preferring embarrassing demonstrations over diplomatic reports. These aren't superhuman abilities. They're choices anyone can make, but they're uncomfortable choices that require giving up the social benefits of playing along. The Challenger investigation ended in June 1986. NASA implemented the Commission's recommendations. Shuttle flights resumed in 1988 with redesigned O-rings. Feynman went back to Caltech, where he continued teaching until cancer finally killed him in 1988. But his appendix to the Rogers Report remains one of the most cited documents about organizational failure and institutional honesty. Here's what matters. Feynman didn't expose NASA's lies because he was smarter than everyone else. He exposed them because he was willing to be the person who brings ice water to a government hearing. He was willing to look naive by asking obvious questions. He was willing to break protocol for truth. These aren't talents. They're choices that carry real costs. Every organization right now has someone playing Feynman's role. The engineer who keeps bringing up the problem everyone wants to ignore. The junior employee who asks why we're doing things the obviously broken way. The analyst who won't sign off on the numbers everyone else accepted. Those people are usually dismissed as not understanding how things work, as being difficult, as not being team players. Usually they're eventually proven right, but only after the disaster they predicted occurs. The question Feynman's story asks isn't whether you can spot institutional lying in other organizations. That's easy from the outside. The question is, can you spot it in your own? Can you see where your company is managing language instead of fixing problems? Where your team is coordinating narratives instead of confronting reality? Where you personally are accepting comfortable fictions because the truth would be inconvenient? And the harder question, when you do spot it, will you bring the ice water? That February morning in 1986, Feynman had every reason to stay quiet. He was sick, famous, respected. He could have signed the diplomatic report, flown back to California, and let NASA's narrative stand. Nobody would have blamed him. Instead, he brought ice water to a government hearing and embarrassed one of the world's most prestigious institutions on live television. Not because he was brave or contrarian by nature, but because once you've spent your life learning that nature doesn't negotiate, you can't pretend humans get to. The ice water test works because it's honest. Water either freezes or it doesn't. Rubber either springs back or it stays compressed. Reality doesn't care about your management structure or your public relations strategy or your career concerns. It just is what it is. And sometimes, the most radical thing you can do is simply show people what's really there. Feynman died believing that science's greatest gift isn't technology or knowledge. It's a method for seeing through bullshit, a way of demanding evidence over authority, demonstration over assertion, reality over comfortable fiction. The ice water demonstration wasn't about rubber seals. It was about refusing to let sophistication obscure truth. That refusal is available to anyone. You don't need a Nobel Prize to bring evidence to a meeting. You don't need decades of expertise to ask for simple demonstrations of complex claims. You don't need Feynman's genius to choose reality over politics. You just need ice water and the willingness to look naive. Somewhere right now, in a meeting room, or a government hearing, or a corporate presentation, someone is managing words to obscure an uncomfortable truth. And somewhere else, someone is deciding whether to be the person who brings the ice water. Feynman's lesson isn't about physics. It's about that decision, and what happens when you make it.